I hope I won't get disconnected now. Good evening, everybody. My name is Diksha Karapurkar, and I will be instructing today's open session. Pravina Research has very recently got ISO certified, and we were thinking that we have to take a bigger leap in terms of taking up an elaborate course on modern workflows of geospatial analysis. And while we were doing this, we realized that Google Earth Engine is essentially something that keeps us away because in our formal education, we were not really having any exposure to coding. Many of us, because we come from either earth sciences background or environmental sciences or ecological sciences or life sciences and things like that, so we were not really having any exposure to coding, and that is what has been keeping us away from Google Earth Engine. Now, in order to take uh, this fear out of us and to get introduced to Google Earth Engine, this 12th open session that is planned um, is uh, is being held live today, and the same will also be recorded and will be available on our website. However, those of us who are attending live will be able to uh, will be able to interact with us, and we will be able to discuss what are the different difficulties that we face or what we are intending to learn and things like that. So let's get started. I hope there is no echo. Is there any echo? Let me know if there's any echo. Okay. Yes. So this particular PPT, we are not going to discuss the entire PPT definitely. Um, but let's just get to know what exactly Google Earth Engine is. It is, as we know, it's a cloud based platform. We need not install any software like how we go ahead with QGIS and ArcGIS or NV or ERDAS, that we have to install within our local device, and then we use the various tools that are available there using all the data that we have, and then we analyze. But when it comes to Google Earth Engine, there is already a repository of vast amount of data that is already available on Google, and from there itself the data is used, and it is analyzed over the cloud itself, such that we don't have to download that bulky data, and also to download the softwares, so that we might not really be using a high end device as well. Most of us might be simply using some tab on a go, and that is when we won't be able to utilize or use QGIS or ArcGIS and such bulky softwares. We need to have a high end system for it, and that might not be very feasible to be traveled with. Now, that is when Google Earth Engine comes to our rescue, wherein we can use this cloud based platform to take up our geospatial analysis, no matter how bulkier they are. We can do them right over internet. Now, so these are our objectives. We are not really going to go through the entire PPT. Let me just rush to this. We are going to understand Google Earth Engine. We'll understand what is its structure, how we can take up basic scripting, what are the principles of this basic scripting, and we will take up some practical applications of Google Earth Engine. Now, why exactly Google Earth Engine? Why not QGIS or ArcGIS, which is a traditional desktop GIS? It has many limitation in terms that, like we discussed, that it has to be installed within your system. You have to have a high end device, and you have to carry your data as well as your tools within this system, and being such a bulky data and this software, it becomes very difficult to every time have access to it. However, when it comes to cloud computing, that is Google Earth Engine, we can carry out our geospatial analysis tasks through our mobile devices as well. So this is the structure of Google Earth Engine. What you see here is an asset manager. Besides that, you will see your documents, and besides that, you will see your script manager. Now in the very middle you will have your um, code editor. This is where you will be writing your script, and besides that you have an inspector that inspects your tool. It tells you what your script is doing. There's a console that prints out the statistics, and it will also show you what are the different errors if you are coming across, and what could be the reason for these errors. Besides that there are tasks, so whatever you do in the scripting and the task that you finish, maybe you want to download something or bring something to your asset, some end product of your geospatial analysis, everything gets populated within this section called task. Besides that you have a map view. Now within this, any data that you wish to view over the map will be visible, so that you will know where exactly your data is lying um, on the face of this planet, right? Now give me a second. Okay, so we are not really going to go through the entire PPT definitely. Let us rush so that we make the best use out of this 1 hour. Okay, all right. So I'm coming to Google, and as I come to Google, I'm searching for Google Earth Engine. Okay, Google Earth Engine. Now, as I search for Google Earth Engine, the first link that I get, I'm going to go here. I must be already logged in, because maybe the Gmail also you must have already logged in. So there might not be any necessity for you to log in. If not, if you are using Google Earth Engine for the first time, this is where you go, that is get started, and here you start configuring your project and create a non-commercial project, because many of us might be simply learning for the first time. So you have to go to my first project, and this is where you are going to make your new project, and make sure that you go for a non-commercial project. Now because I have already made a project, I will directly come back over here, and I will be going to platform. Under platform I go to code editor. Okay, so as I go to code editor, you will see the same structure wherein you have scripts written, scripts stored over here, your scripts are managed over here, your documents are managed over here, or your APIs, if you want to find out which are the different algorithms, what are the different dictionaries, anything, all the APIs will be stored over here. Besides that you might also have some data that you want to store over cloud. It is not really available on Google Cloud, but it is some data that you have. For example, if it could be some watershed boundary, then it is not available on Google Earth Engine, let's say. So what you have done, you have brought it and kept it over here. Okay, so you go to new, whether it is a shape file or a geotiff, or whether it is a CSV file, it's an image collection, or it's a folder, you can choose and upload that particular file over here, such that it will be available for you to be used within your scripts. Okay, now besides that you have a code editor over here. This is where your script will be visible. This is where you are going to write your script, and here your code will be inspected. All the layers that you add will be inspected. Besides that you have a console. This is where your statistic, if you want to print something, then that with some text, if you want to print some associated metadata that you want to print, that will be printed over here. If there is any error as well within your script, that will also show up here. And besides that there are tasks. So whatever geospatial analysis that you complete, and you wish to import it, or sorry, export it into your Google Drive, or maybe in your assets, then this is where it will be populated. All right, now coming back to the script, this is where we are going to write our codes today, and this is where you have your map view. You can look at a map view, you can also have a terrain view if you want, or if you want you can also go for satellite. So whichever you feel more suitable, you can definitely choose that one. All right. Now coming back to our presentation, the first exercise that we are going to take up, we are essentially going to complete five very small exercises today, so they are not going to be very bulky. The first exercise is wherein we are going to import and display Delhi using the global administrative unit layer of level 2 dataset. Now these are also collections. Okay, so GAUL level 2, this is also a feature collection that is stored on Google Cloud that essentially helps us locate different administrative boundaries and to use them for our various geospatial analysis. So today what we are going to do together is we are going to import and display the administrative boundary of Delhi. Now, the same code can also be used for different other purposes. We will first try to break this down into four different steps and try to understand what exactly this is. And then we will move ahead to see how we can do this particular coding within ChatGPT without really going through the elaborate coding. Okay, so let us go ahead. So what you see here is we are loading. So the first step is to load this GAUL level 2 administrative boundaries for the district. So we are taking a variable. The variable is called GAUL, and this is the API. Where do we get this from? We get this from the vast amount of repository that is available on Google Earth Engine. For that, what we can do, we can go to the docs, and might be a little difficult to look out over here, but then we can search over here. So we can search for places and data sets. You can search for GAUL. Let us search for GAUL, and here you have different types of data sets. Okay, different data sets are available. So this is first level, this is second level administrative units. So let us go here. So when we reach here, you will see the collection snippet. So this is the API. This particular code will help us to bring this feature collection that has administrative boundary for every district in the entire world. It will also have talukas. Okay, let us go ahead and copy this and come back to our script. So what we are going to do, this is to comment. So when you have two forward slashes, that helps you in putting up a comment. Okay, so what we are doing, we are importing administrative boundaries. Okay, I hope I'm audible. Yes. Okay, so where we are bringing this from, we are bringing this from GAUL level 2 dataset. What this data set has, it has administrative boundaries for any and every district as well as taluka all over the world. Okay, so we are going to call this GAUL, and that is a variable. Okay, so that is a variable. So the first variable is GAUL is equal to, paste this. So this, what it is going to do, it is going to bring up the GAUL data set. Okay, coming back. So once we do this, you can also use the other different levels that are available over there as well. Okay, so there were different types of data sets. You can choose whichever that you want. Then the next thing is we have to filter it for India and then for Delhi, right? So unless and until we filter it, because everything must be there, we have to filter it down to first our country and then go ahead and filter it to Delhi. Now for that, what we are going to do, we are going to use this filter function. For that, what we are going to do, we are going to first filter it to India, and then we will filter it to that of Delhi. So coming back, let us go for the second step. The second step is filtering to Delhi. Okay, so we will filter it to Delhi. Give me a second. Okay. So the next is again variable. What is the variable? This time we are going to first filter it to India. That is where we are going to start from. So the next variable is India. And we are going to filter what? We are going to filter GAUL, correct now? So GAUL is this variable that we are going to filter. And how do we filter? We use the function filter, and then what we are going to filter, we are going to filter using this API, that is ee filter dot eq. And then again, these are what I'm going to add now, that is admin name. This is essentially the attribute value. Okay, so this is what it is called within the admin, within the attribute table, that is placed within this, that is attributed to this feature collection, that is GAUL. Okay, so when you open any vector data, it has different attribute information, isn't it? It might have area, or it might have length, it might have perimeter, it might have a specific name, maybe a proper name, and things like that. There might be x coordinates or y coordinates, latitude, longitudes will be there. So these are the different information pertaining to each layer that is present, or each feature that is present within that shapefile. So similarly, when it comes to this feature collection of GAUL level 2 data, there the admin name is written, and the admin name has this particular you know what do we call it, uh, this particular header name. Okay, the column information is this. So what is that column information that we are interested in? We are interested in India. Okay, so that is where, then uh, use the semicolon so that you are continuing. So the next thing that we are going to do is, yet again, you can copy the same thing and paste it in over here. But this time the variable that we are going to go for is Delhi. So this time we are going for Delhi. Yet again, the admin name, this is admin zero name, that you have to remember. Zero is for country, and then one is for district, and two goes on for taluka, and then furthermore, if there is at all any more data that is available, then it will be available at the fourth level, and things like that. So at first admin level, what do we have? We have district. So what we are going to write here, which district we are looking for? We are looking for Delhi. So Delhi will come over here. Now as we do this, what is going to happen? Our GAUL level 2 data will be filtered from the entire collection. It will be filtered to country, and from countries it will be filtered down to the level of district. Now after this, what we are going to do is, we are going to first merge all the levels, or all the different features that are available for Delhi. And now in order to do that, we have to take a union of all this. To take a union, let us take, sorry, variable, yet again, Delhi, and we will call this geometry. Okay, I'm just calling it geometry. You can give it any name, but basically we are only making a union of all the Delhi files that are available. Now in order to do that, what do? We take the Delhi variable. You can see it over here, the Delhi variable that we are going to use. And as we use this Delhi variable, then you have to give another function, that is to make a union of it. Now as we make a union of this, that will be stored within this, you have to take a geometry. You have to convert it into a geometry. Now as we do this, we should have, sorry, not here, we should have the geometry sorted. Okay, so once we do this, let us go ahead and add this to the map. So the next step is to add it to the map. Add to map. Unless and until we add it to the map, how do we know whether it has been completed or not, isn't it? So in order to do that, what we are going to do, we are going to first add it to the map. How do we add it to the map? The function is map dot, we have to center that that particular shape file on the map. Okay, so center object, and what exactly we are trying to center, we are trying to center Delhi. Okay, we are trying to center Delhi at a scale of 90% maybe. Okay, so there's not much to do with it. You can also take it as 10, not a problem. I hope there's no echo. All right, and as we do this, let us add this layer. We add this layer, that is Delhi. This is the variable that we are talking about. Okay, this union we are going to use a little later. So Delhi, and we have to give it some color. So color is also important. So for color, when you assign color, make sure that you go for these curly brackets. So open this curly bracket. The color, let's say that we want to assign to it is maybe blue. Sorry, let's say we want to assign blue color. So assign blue color to this, and then uh, we will call this something. What do we call this? Maybe Delhi boundary. So this particular name that we write over here will show up within that layer section. Okay, so let's call this simply, if we call this Delhi should also do. Let us save this file as os1. Save this, so it will be saved within your scripts. As this gets saved, you can run this. Mm, oh, your functions will come as this purple color. I hope I'm audible. Okay, so this is our first exercise. But then what if we don't really know how to code all these things, isn't it? So that is exactly what we are going to look into. So we come to ChatGPT. I'm using a free version of it. Okay, I'm using a free version of it. I'm not using um, any paid version of it, any subscribed version of it. Let us come here and give a prompt to ChatGPT, a very simple prompt to ChatGPT, so that it will help us in generating the same code. Okay, so we come here, we have to give it some prompt, and make sure that your prompt is very precise and very clear, so that whatever you ask ChatGPT to give you, it is going to give you the proper functioning script at the very first go. Okay, so let us ask it, let's give it a role. So we decide a role to this chat gpt so that it will be able to concentrate all its understanding into the geospatial analysis for cloud computing, essentially using Google Earth engine. Okay, now you have to tell it what it has to do with all this expertise, with all this knowledge, what it has to do. To extract, uh, let's ask it something else to do, maybe nothing, something else than Delhi. Extract boundary of some district. If anybody would like to tell me which one we should try, then you can definitely drop me a district boundary. Is there anything specific that comes to your head, or you can also unmute yourself and tell me if at all. Yeah. uh, let's say Mangalore, unless you have some other suggestion. And it has to be displayed on the map. Okay, also let's go a little beyond. Also create another area of interest, that is AOI, with a buffer of maybe 2000 meters around Mangalore. Display the same on the map. Okay, it's very simple. We are not really coding anything. Let's wait for it to give us the code. And definitely the first time that it gives you code, with in spite of taking so much of care, it might still have some error. But we should not be so much bothered, because any AI agent will be able to solve its own difficulties as far as you are giving it all the errors that you are facing. uh, district name is, so it's just thinking, it's thinking. Okay, Dakshin Kannada and Mangalore. So what it is doing is, oh, Mangalore is not a district. No, the district is Dakshin Kannada. Yes, pretty huge. Let's see. I will have to change this to Dakshin Kannada. But let's come back. Paste this here. Let's save this and run. So we are getting Mangalore center point and 2 kilometer buffer. Let's see what exactly. Center, it has taken a point, and it has taken a buffer. But this is definitely not something that we want. It's taken a buffer around, so it has not really understood. Maybe I have not given it a proper uh, instruction. Let's change this. We will change Mangalore to Dakshin Kannada. Okay. Now it won't be confused because earlier we told it Mangalore and then it got confused. So it's still doing the same thing. It is using GAUL, the same feature collection, and it is sorting it to first Karnataka and then to Dakshin Kannada. Right? So it's again making a union of it. But why is it taking a point? It's not something that we want it to do. Some stuff. Okay. Let us just ask it to do the first thing first. Stack administrative boundary. Only this much. That's all. Okay. While I do this, I suggest that you also do something. Okay. So if you are facing some difficulty, you might be facing some different difficulty than as compared to mine, and we should be able to sort both. The feature is required and may not be null. This seems to be something that is not there. Let us change this. We will change this to change this to maybe Kerala. Let us change this to Ernakulam. Might be spelling it wrong, I don't know. Oh, this also we have to change. Okay, it is showing Ernakulam. Might want to also remove this. Should do. Ah, just delete this. Let's give some other. Maybe Thisur. Okay, but that's the only one that it is displaying. That is, it is calling. It's still calling it Dakshin Kannada because here it is called Dakshin Kannada. Let us change this to Ernakulam. Save and run. So now you will see that it is shown as Ernakulam. Okay. Okay. So we did the same exercise yet again using ChatGPT. And it was definitely very easy provided we don't mess up with the code and that we are slightly concerned about what exactly we are giving as a prompt to ChatGPT. Let us go ahead with the second exercise. So the second exercise is wherein we are adding Sentinel to True Color clipped to Delhi. So here what we are doing, we are importing Sentinel to surface reflectance data. Now you might be wondering where exactly do we know that this image collection snippet is called this? How do we call for the Sentinel to surface reflectance data. Now for that, what we have to do is we yet again go here and search for Sentinel 2. Now as we search for Sentinel 2, you will see that there are different data sets that are available. These are from Sentinel 5, but we are interested in Sentinel 2. uh, okay, let's go searching for in over here, browse data catalog. Let's browse through this catalog. So here we have different types of data sets. Within that, you also have Sentinel. Okay, so we go to Sentinel. Let's go to Sentinel, and here you will see Sentinel 1, Sentinel 2, but then we know we want multispectral instrument data. Okay, so MSI is the data that we want. So for that, we go to Sentinel 2 MSI, and here you have surface reflectance, you have top of atmosphere reflectance. We will go for surface reflectance because this is level 2A data, that is atmospherically corrected, and you have a surface reflectance. The data is available right from 2017, that is March 28th onwards. We go in here, and this is where you will see Earth Engine snippet. Okay, so this is what we require. So we can copy this, and we come back here, and we go for importing Sentinel 2 data. Okay, that is SR data. SR is surface reflectance data. This is level 2A data. So here yet again the variable we have to call it, we are, let's call these Sentinel 2. Okay, for Delhi, Sentinel 2 for Delhi. So that is, this snippet is what we is going to call for the data set. Okay, so once we bring in these Sentinel 2 data, we have to filter it, because as we saw that the data is available ever since 2017, isn't it? But then we might not really be looking for the entire set of data. That could be hundreds of data sets that are available for the region, that is Delhi, but then we are not interested in everything. We are essentially interested in filtering for a specific time period, and for the bound, that is for the area of interest that we have selected, which is Delhi. And then we would also want to filter it for the cloud cover. Let's say we want the cloud cover to be strictly less than 10%, and only that data set we want to use. Now it could also be that for the temporal period that you are looking the data for, it will be carrying multiple data sets, isn't it? There could be many scenes that were taken during that particular time period. So you would want to go for taking a median of all those data sets that lie within this time period for this particular boundary, that is Delhi, having cloud cover less than 10%. And that is when you go for filtering it. Now how do you go for filtering it? Let us come back here, and we will try to filter this. In order to filter this, we are going to filter by date. So we filter by date. Which is the date? We will choose some starting date and some ending date. What should be the starting date? Let's search for something very recent, maybe 2025. So 2025, which month? Maybe January, or better February. So February 1st, and then the end date is again 2025, then again second month, let's say 27th. Okay, so until here, so this is our filter, first filter. The second filter, we are going to filter it by the bound, that is the boundary. Okay, so what exactly is the filter bounds? The filter bounds, we have called it Delhi, right? So we have called it Delhi. We have to make sure that we are taking the proper name. So there should be absolutely no spelling mistake there. The variable that you have chosen, or um, on top, the same has to be taken up over here. Okay, the spelling. Okay, so this is the second filter. The third filter that we are applying is that we have to filter it as per the attributes of this particular image collection. So what exactly is that attribute? It is cloud cover. And this cloud cover, this attribute, has a very specific name. How do we know what exactly that name is? For that, you can come to, yet again, here in the description. If you go to bands, let me just look out for it. So you get these filters over here also. So here you will see that filter it by cloud pixel percentage. So here it is 20. So let us take this and bring it to our script. Just paste it over here and change this to 10%. You can even take this as 0%. Okay, so we have to have that in our mind, that there's not a problem even if we take it to be 0%. So all those data set that do not have absolutely any cloud cover will be shown up. Now what will happen, all those data sets that were taken, all those scenes that were captured between this time period, will be considered together to take a median. But if you want to take up only one data set, then you don't go for this median. Okay. Or what you can also do is you can minimize this time period such that only one or two data sets are available, so that everything is covered, like the entire region of Delhi is covered. So you have to have at least two data set. There could be one scene that is partly covering your admin boundary, and partly the other adjacent scene is covering. So once this is done, let us go ahead, and we have to definitely visualize this, isn't it? So to visualize this, let's populate the scene on the map. So how do we populate this? Yet again, let's create a visualization that is also going to be true color. We will make a true color composite. In order to make a true color composite, we have to make sure that we take some bands. Some bands have to be taken. So what are those bands? Those could be any bands that you want, because we are making true color composite. You can go back to the information of this data set, where you will realize that band 2 is blue band, band 3 is green band 4 is red band. So if we want to display true color composite, then we have to take a combination of red color to red band, green color to green band, blue color to blue band. So it is 432. This is the combination that we have to use. So come back, and they are called what? They are called, because we should also know what exactly those bands are called, no? So it is B4, B3. Every time this band might not be called the same thing. It could be SR underscore B1, like how it is for Landsat data. So you have to be aware as to what these bands are named. So here they are simply named B1, B2, B3, right? So let us go ahead, come back to the script, and this is where we are going to take the square brackets, and here we will use band 4, then band 3, and then band 2. So in this particular order we are going to use them. Oh, just make sure, because they are something very specific, isn't it? So we have to put them into single quotes, because that is something that is being referred to the data that is available within that image collection. Now, what should be the value of these reflectance? Uh, I'm thinking that minimum it could be maybe 0. Okay, minimum could be 0, because on a scale it has to be displayed, isn't it? So minimum, let's say 0 is the reflectance, because reflectance is not going to be negative, isn't it? And then the maximum, let's say 4000. 4000. So we are assuming that the value of reflectance is not exceeding this particular value. Okay, and then close this curly bracket, close this curly bracket, and then put a colon and come down. We are going to populate this on the map. Now in order to do that, what we are going to do, we are going to take, I mean, we have to first clip this, isn't it? So let us clip this. So take another variable, that is delhi underscore true color composite. Okay, delhi underscore true color composite, and this is going to be our tcc. No, sorry, this particular variable that we are going to clip it, and the function that we use is clip, very straightforward. And we are clipping it to what? We are clipping it to this particular variable, that is delhi geometry, that is we have made a union of it. No, this is the one that we are going to use. So paste it over here. Once this is done, we are good to go and display it on the map. So let us add this to the map. So map, add layer. All these functions you need not really remember them. Okay, because it is not about we answering some exam. Everything is available within this docs. Now, so we are going to add the layer, that is the true color composite, to the map. And what exactly it is? It is this layer that we are going to add to the map, and the true color composite, and we have to call it something so that it will be seen on the map, how these layers will come. No, so here let us call this again delhi tcc, and it is march, isn't it? March 25. So once this is done, we are good to go. Let us populate this, save, and run. So everything makes sense when we are really writing the entire code. That is the first step to go ahead. We have to understand what exactly needs to be done, what exactly is the order in which our code has to be available, so that it will function effectively and that there won't be any error. Now if here there was to be some cloud, then what we could have done, we could have changed the date range. So right now it is taking into consideration the entire month of february. Let us bring it down to maybe 10th of February. Let's save this and run this again. Okay. So like this, you can change the time range as well. So once this is done, let us go back to ChatGPT. Okay. So here, what we are going to do, we are going to tell it create a AOI, that is area of interest, for Ernakulam district plus 2000-meter buffer. I would really want to go one step beyond and just try something new, isn't it? So 2000-meter buffer, um, and import Sentinel-2 dataset for the same. Display a true color composite on the map. I think it's time to open a new file. Let's make a new file and we will call this um, AI trial. Okay, call this AI trial for Ernakulam district, 2 kilometer buffer and a true color composite. So let's copy this code and we will identify this. Let's paste this over here, save and run. So it's creating a buffer and it is also creating Sentinel-2 collection, but it is not clipped. Okay, so it's not clipped. We have to mm, make sure that it gets clipped. Okay, so it's displaying the entire scene right now, not only for Ernakulam. So come back, rewrite the script such that the Sentinel one is clipped to Ernakulam plus 2 kilometer buffer. Yes. Okay. So what it is doing, it is creating a buffer of 2 kilometer around the district and it is loading the Sentinel 1. Okay, not Sentinel 1. We were interested in Sentinel 2, sorry, not Sentinel 1. Sentinel 1 is SAR data. Do this for Sentinel 2. Okay, so it is doing this for Sentinel 2. Let's copy this, come back here, delete, paste this, save and run. Okay, very simple and very quick. Okay, so why I have taken this 2 kilometers of buffer, just in case if I need to do some geo referencing with respect to some other data, then I have to have a little more area and not just only at the boundary, isn't it? So that flexibility I require, because of which we go for taking a buffer of 2000 meters all around the administrative boundary. So this is how things are becoming much more faster. Let us ask it now. Give me the next part of the code to extract or to compute NDVI for Ernakulam using the Sentinel-2 data imported. And then we would also want it to be displayed, isn't it? So display the same on the map. So we don't really require the previous part, we only want to go ahead. So that means what? That the AI agent has to remember what were the earlier uh, variables named. Okay, so let us copy this, come back here, paste this here, save and run. So we have NDVI as well getting populated. Let's wait. So this is for Ernakulam and this is NDVI. Now again it is 2000 meters buffer is also available, which means if at all I want to do some geo rectification, then I will be able to do. But the problem is this data is right now available on cloud, isn't it? Which means what, every time I will have to run this to be able to see it. But what if I was able to download this particular NDVI map, so that what I can do right now, I have done this for the month of December 2023. I can do this for December 2024, 2025, and so on and so forth. So what is going to happen? I will have many NDVI data layers that are available, and then I can do some temporal analysis, right? So for this, what do I need to do? I should be able to export this. Now there is this one problem that is associated with Google Earth Engine. You cannot directly download the dataset within your local device. So you have to first export it on your Google Drive, and from Google Drive you will be able to download it. So for that, let us go. Write the next section of the code to export the NDVI. Let's say I don't want anything else. I only want NDVI. NDVI layer of vernaculum to my Google Drive folder, and let's give a name to this Google Drive folder, isn't it? So what should we name this? Ernaculum. Ernaculum NDVI. So no matter what kind of spectral index that you are trying to compute, whether NDVI or normalized difference water index or burn index, or any kind of, you should be able to do this. Okay, so folder is there, and the scale is 10 meter. That is correct, because Sentinel-2 itself is 10 meter resolution. Let us go ahead and paste this. Ernaculum NDVI. What was this called? NDVI clipped. So it was not called Ernaculum NDVI. Okay, that's not the name. The name as a NDVI clipped. So NDVI clipped, this is the image that is getting exported, NDVI clipped, and this is where it is. Okay, it was clipped to the Ernaculum buffer. Let us save this and run this. Come to the task, and this is where you will see that NDVI Ernaculum is ready. What if you want to change the name of this particular file? Very simple, you can do this after running this particular task, definitely, but before that as well you may do this, because we are doing this for December 2023. Let us write this, December 2023. Okay, and then let us save this and run this again. So now you will see in task, within the task, NDVR, oh, we have to change it over here. The description needs to be changed. Okay, so save this, run this. So after this, even if I don't make any changes anywhere else, but I change the starting and end date over here, for that is used for filtering the data set, and if I change this particular specification here, I should be downloading the data set properly. Okay, that means along with the name of that particular month and the year. So let us run this. It is coming to NDVI and Ernaculum NDVI folder. The file format is GeoTIFF. Let us run this. And now we can go to our Google Drive. Let us go to Google Drive. And here there has to be a folder automatically made. So we go to our drive, and that is where we have to look out for Ernaculum NDVI. Okay, so right now it has not come here because the task is still running. Okay, task is still running. Now often it might so happen that we will lose a little bit of our patience, and we will try to give a huge instruction to prompt to the to any chat gpt, or maybe uh, Gemini or anything like that, and then we will get many errors. So if we solve one error, then the second one pops up. If we solve the second one, the first one pops up. But if we go in this order, if we know what are the different steps that have to be taken in order to achieve the kind of analysis that we are doing, so that we will also be able to download the data set, we have to go in a structured and an ordered manner. Okay, and when we do this, definitely it will take a little longer than being impatient and giving the entire code and getting the entire code in one go. It will take a little longer, but definitely you will feel more sorted, and you will be able to complete the task within lesser time as compared to just giving the entire um, prompt to chat gpt or anything. Okay, so it has to finish so that it gives you a tick mark like this, and then it will be populated within this particular folder, and from here you can download it and visualize it in QGIS and go ahead and maybe make a map out of it. Okay, all right, let me come back to you. Do you have any question? Yes, so it will ask you to uh, register for a new project. So for in that case, what we do is we go to get started. See, yeah, you go to get started, and you will say that it is my first project, right? So let's say if it is my first project, so I create a new project, give the name. You have 9 projects remaining in your quota. Request an increase or delete projects, so I might have to delete some projects. Okay, so make sure that the organization that you give should be some academic organization, or maybe just absolutely nothing and something like that. Okay, so let me try, because I have already made my first project. I don't know whether it will allow me or not. So let me give it a name. So partial. Uh, no organization is fine. Create. So this non-commercial data set, no, it takes a little longer, maybe 2 or 3 hours to set the first time that we do. So create project, special, select project, select a project, that is geospatial project. Now viewing project geospatial, go to setting, cloud access block. Google Cloud Access is blocked, effective from uh, to turn on two-step verification. Okay, good. So this is my trouble enabling. Okay, all right. So you have to provide your password over here, or that you tried using ChatGPT or any other AI tool to form your G scripts. But then, if you are facing any difficulty, or that it worked out for you, you can share that. So there were essentially 5 different exercises that I was intending to complete. So one is definitely importing and displaying any administrative boundary. Second is adding Sentinel-2. Now similarly, what you can also do is you can use Landsat data, or if you want to use Modis data, then that also you can use. Each one of them will have a Google engine snippet. You just have to identify which snippet it is. Often even your AI tool will also tell you what exactly is the Google Earth, that is G snippet of this particular data set that you are trying to explore. And but if it doesn't work, then prefer to go by yourself and check out what is the correct snippet and things like that, because often what happens is that uh, the collection name might have changed, or the data could have been shifted on a different collection on the cloud, and that is when some changes in the uh, this Google Earth Engine snippet also happens, and then we will be stuck. So but then within the console itself, you will get an error saying that this particular collection has not been identified. Okay, so that should be your clue to understand that the collection is different. So then next was to compute ndvi. So if you have understood how to compute ndvi, then you need not even go back to ChatGPT or any other AI tool to change this to any other normalized difference spectral index. For example, if it is ndwi, you can do that simply by changing the bands. Then exporting the shapefile, you can use this particular script to be able to download or export your shape files if at all you want those, and that is to export the raster file. Okay. Okay, so this is a test that I have prepared. There are 5 questions. You may quickly either scan this, or I am also sharing this particular link with you in our chat box. You can answer this, but attend to this particular small quiz is there. Some 5 questions are there. You may attend to this, and this is for your feedback. Okay. Let me share this link as well. So your feedback is going to help me in organizing any further open sessions. And if you have any suggestions about this particular topic can be taken up for the next open session, then definitely feel free to drop that into our suggestions within the feedback link itself, so that uh, we will discuss and we will think about floating yet another open session on a topic that you choose. Thank you.